Okay, we are ready to start solving exponential equations using logarithms, and so this will allow us to solve pretty much any exponential equation you'd see in an algebra class. And before I do this, let me give you the strategy. The first thing you want to do is look for a common base. If you can find a common base, you probably don't have to use logarithms, and that'll make it a lot easier on you. And so look for that first, but if that's not possible, we move on to number 2 and we look for an e. If there's an e involved in the equation, that lets me know that I'm going to have to use ln. And so what I'll do in that case is I'll take ln of both sides. What I mean by that is I apply the ln function to both sides of the equation. So if there's no e involved, and even though I took ln of both sides in that case, we're going to have to just take a logarithm of both sides, and it could be ln or it could be log. Alright, so we're going to take log, and here we'll say or ln, and we want to stick with ln or log because then we can use our calculator of both sides. So let me show you how to use this strategy through some examples. If you have any questions, just let me know and I'll help you solve them. Alright, so for these first two, we have to solve the following, and look at part A. We have 4 to the 3 minus 2x power equals 7. Okay, now according to my strategy here, first thing I want to look for is a common base. Can I relate the bases of 4 and 7? Can I write 7 as 4 to some power? Probably not, so that's going to be gone. There's also no e involved, so what I'm going to do here is just jump to part 3 of our strategy and just apply log to both sides. So I'm going to say log 4 to the 3 minus 2x equals log 7. Okay, now why is that helpful? Well, mainly the reason we apply logarithms is it helps us take variables out of the exponent. Because remember, the third property of logarithms says something like this. Log base a of x to the r power is the same thing as r times log base a of x. So in other words, the exponent can come out in front. The variable being in the exponent is what made this complicated to begin with. This property will allow us to get rid of that difficulty. So what I'm going to do here is I'm going to take out that power because I'm allowed to do that with a logarithm. So I have 3 minus 2x times log 4 equals log 7. These look ugly, but remember they are numbers. So now we have a linear equation, just like everything we've done in the past. I'm going to divide both sides by log 4. So I have log 7 divided by log 4. And now I just need to solve for x. So I'm going to say negative 2x equals this ugly number, log 7 over log 4 minus 3. And then I divide both sides by negative 2. Or you can say negative 1/2 times all of this, log 7 over log 4 minus 3. And that is a number, so we carefully put it in the calculator, and you should get approximately 0.80. Okay, and I do recommend playing with your calculator and making sure you can get that value. Depending on your calculator, you have different syntax. Alright, I hope that makes sense. Keep in mind, again, once we get to this point, we are just treating this like a linear equation. This is just a linear equation. So we didn't do anything new after that point. Okay, all this other stuff is just what you've done way back at the beginning of algebra. The only new part is just taking the log of both sides and using the logarithm to take the variable out of the exponent. Let's look at part B, and it's going to operate a similar way. Okay, there's no e, I can't get a common base, so I'm going to take the log of both sides. Actually, this time let's say ln, just for fun. So I have ln of 8 to the 3x plus 2 power equals ln of 7 to the 2x plus 3. And now I'm going to use my properties of logarithms to take out those exponents. And now it's a linear equation, and I got to solve for x. And so I need to get all the x's on one side. Because of that, I need to go ahead and distribute my ln 8 and my ln 7. So when I distribute the ln 8 across, it's going to look ugly. Okay, but I have 3x ln 8 plus 2 ln 8 equals, and now I'm going to distribute the ln 7, so I have 2x ln 7 plus 3 ln 7. Okay, now keep in mind, look, the 2 ln 8 and the 3 ln 7 are real numbers. They look ugly, but they're real numbers, and they have nothing to do with x. So I'm going to bring those together. On my left-hand side, I'm going to have 3 ln 7 minus 2 ln 8 there, okay? On the right-hand side, I'm going to bring together everything that is not a real number and everything that has a variable in it together. So here I have 3x ln 8 minus 2x ln 7. And the reason I did that is because now I can factor out an x, and when I do, I'm left with 3 ln 8 minus 2 ln 7, and I wrote it in green on purpose to show you that that is all just a real number, equals 3 ln 7 minus 2 ln 8. These are all numbers. So finally, I have x equals this 3 ln 7 minus 2 ln 8 over 3 ln 8 minus 2 ln 7. Can we simplify any? Can I cancel out the ln 7s or the ln 8s? I cannot. I could use some properties of logarithms to simplify the numerator or simplify the denominator, but I don't think it'll help us any. In fact, all I need to do now is just plug it into my calculator, because ln is something we can calculate, and carefully do that and make sure you get 0.72. So you should practice to make sure you get that in your calculator. Alright, let me show you a few more. Okay, now for part C here, we have e to the 8x plus e power equals 8 to the ex plus 8 power. That's interesting, just the symmetry there. And I see an e, right? So I cannot get a common base, but I do see an e, so I know I'm going to take the ln of both sides, and that's exactly what I want to do. I'm going to say ln of e to the 8x plus e power equals ln of 8 to the ex plus 8 power. Okay, on the right hand side of the equation, I can see that I can just pull out my exponent like I have here. So I have ex plus 8 times ln 8. What about the left side of the equation here? Well, if you remember, there is a property of logarithms that says log base a of a to some power simplifies just to being that exponent. Okay, so here ln, which is log base e of e to this power, is just going to reduce down to the exponent 8x plus e. Okay, and now it doesn't look like it, but this is a linear equation here. I'm going to distribute the ln 8, so I have 8x plus e equals ex ln 8 plus 8 ln 8. And now, just like last time, anything that does not have an x in it gets brought to one side. Everything that does have an x in it gets brought to the other side. So I end up with 8x minus ex ln 8 equals 8 ln 8 minus e. And now I'm going to factor out my x on the left hand side, and I have 8 minus e ln 8 equals 8 ln 8 minus e. It looks ugly, but these are real numbers, okay? They are real numbers. So here I get x equals, finally, 8 ln 8 minus e divided by 8 minus e ln 8. Okay, and I can put that in a calculator very carefully. And when you do, you should get 5.93 as your approximation. And I hope that makes sense. Okay, we're doing the same thing. It's just we're doing linear equations. Actually, they just look a little different. All right, now on to part D. Okay, so I could take ln or log of both sides, but remember the first part. Look for a common base. And what I recognize instantly is that 36 is the same thing as 6 squared. So I have 6 to the 3x minus 4 power. Instead of saying 36, I'm going to say 6 squared raised to the 2x plus 4 power. And you know what? I'm going to go ahead and write that like this, because I can multiply the 2 across and get 4x plus 8, right? When you raise powers, you multiply them. So now I have 6 to the 3x minus 4 power equals 6 to the 4x plus 8 power. Since I have a common base, I don't even have to worry about the bases. I know that the exponents have to equal each other. So I know that 3x minus 4 has got to equal 4x plus 8. Okay, so that's a simple linear equation, right? In fact, I'm just going to subtract the 3x from both sides and add 8 to both sides, and I get x equals 4 as my solution. And I hope that makes sense. Guys, exponential equations can be tricky because there's different approaches, right? But I think if you learn this strategy that I gave, you'll be able to be successful in your algebra class with exponential equations. So again, the strategy is first look for common base. If that doesn't work, look for an e, because then you can take the ln of both sides. And if all else fails, take the logarithm of both sides. And you can either use log base 10 or ln, and from there you can get your answers. If you have any questions on this, please let me know. I'd be glad to help, and thanks for watching.